Hello everyone. Hi. It's morning hours. Good morning. Myself Shivam Sharma. I hope I'm recording the screen properly. So today we are going to learn and understand a bit about network meta-analysis. You can consider this as an extension of meta-analysis. Um, so that's my thought process. Because in meta-analysis we are having direct comparisons only. For example, we can directly compare A versus B, B versus C, because these are the studies which are available with us. But in a meta-analysis, I cannot compare A versus C because that meta-analysis is not having that um, feasibility of comparing indirect studies. So that's where network meta-analysis comes handy. It is a powerful tool in which we are having a lot of options to play around with indirect comparison. Uh, but that's really helpful for clinicians and as well as patients in shortage of studies comparing drugs. Like for example, the comparison of A versus C may take a lot of time for conducting RCT and then getting the result. But through creating a network meta-analysis, we can compare it. Well, there is issue with transitivity and consist and we do can compare A versus C. For example, let me give you a hint over here. This dotted line, straight line is representing a direct comparison. Well, keeping this B as a common intervention, we can do compare A versus C in this network meta-analysis. So this is the indirect comparison which we are doing when we don't have studies directly reporting A versus C. So this is what we are actually going to do in today's video. We are going to run network meta-analysis for count outcome, that is dichotomous outcome, using netmeta package. We will be using frequentist NMA method. There are two kinds of thought process. One is Bayesian and one is frequentist. So currently we will be using frequentist method to conduct network meta-analysis. So getting straight to our studio. So yeah, as always, we will be checking just the codes of how to running. Following this, in the next video, we will be discussing outcomes. So this is the data set. I've already installed it, so I won't be reinstalling it. So we can go through this data set and check what are the number of columns, what are the number of rows which we are having. So we are having nearly 10 studies. We are having interventions comparator. This is hypothetical situation. This is the intervention sample size, comparator sample size, hospitalization, and adverse event. So I will be doing this network meta-analysis just for the hospitalization outcome. I will be sharing this data set with you. It would be good if you want to learn NMA, you can just download this Excel sheet, install it in your RStudio, and then you can run outcomes for this adverse event so that after watching the video you can actually implement it too. So going back to the codes, so I did have already installed netmeta, so I'm not gonna rerun this code now. As I usually do that after installing any package, I write a question mark and I feel that it's better to go through the details which are provided in the netmeta, so you can go through it. So for this binary outcome, we are gonna use a netmeta bean function to run our network meta. Go through this netmeta bean for understanding what are the elements getting inside this argument. Okay, so this is a network meta-analysis for binary outcome. So this is how we're going to use it. It's even one sample size of intervention maybe, then even two sample size of comparator, treatment one, treatment two, and study labels. data set which you're going to use, and SM which we are going to use at odds ratio. Let me read slowly. Um, this loom is good, but it takes time to shuffle this from base to the upset, the first quadrant. So yeah, let us run. I'm going to name it as anime hospital, anime house, in which I'm going to use meta bean. The data we are having network because we have installed this data set in the form of net means we have named the data which we are going to use as network. So data will be network, treatment one will be network intervention, event one will be the hospitalization uh, events, sample size one will be intervention sample size. Similarly, treatment two, event two, and N2 are comparators. Treatment, events, and sample size. Now, stud lab, sorry, is the study labels. That's the name of the authors followed by their publication year. And then we are going to use odds ratio. So let us run it. So no red marking, I guess it's running still. Yeah, it's been executed. Let us check the summary. Okay, a lot of information. So yeah, we do have 10 studies. Here was comparison, number of observation. I guess those are total number of observation, number of treatment 8, and number of design. So this is the comparison between, obviously we cannot compare where artemisinin versus artemisinin, but comparing artemisinin versus artesunate. Similarly, sorry, artemisinin versus chloroquine. So this is the comparison which has been provided in terms of odds ratio. This is the lower limit and this is the upper limit. Don't worry, we obviously will be going making another video for better understanding of what are the outcomes reported over here. Okay, in network meta-analysis, there are usually three things which are important. Most important, I would say. First is league table, other is Sukra, and the third one will be the diagram, that is network meta-analysis graph. Well, obviously there could be other things also which may be more important than this, but through this three things you will be able to understand how is the comparison going on, what is the ranking of your respective drugs, and how the graph is visually looking, whether it's a star shape or it's entirely a circular form or it's just a triangle. So this is the league table. For league table, we're going to use net league function. So yeah, this is the league table which is provided over here. It's a bit clumsy, I would say, because it's not getting fit into this entire screen. It should have been in a single line. No issue. We will convert this into PDF and we will look to it. Now getting to the Sukra, which is surface and cumulative ranking curve, it helps you to give ranking to your respective drugs based on the outcomes which you are comparing. So yeah, let us run this. So we are going to use net rank function to get the ranking. So yeah, we are using the P score. You can also use Sukra. Both ranges from 0 to 1. 1 means better and 0 means in terms of ranking, 1 is better and 0 is least. So this is the clindamycin. I guess this is having the least number of hospitalization. I guess that's how it's working. It is artesunate had the most hospitalization events recorded. So yeah, in terms of hospitalization, clindamycin is better than compared to artesunate, whereas placebo is ranking somewhere in middle. Okay, leave this section. Yeah, so creating this network figure, we are going to use netgraph function. Okay, so yeah, this is our network plot for hospitalization outcomes. Sorry, yeah. So I'm going to this figure itself. I can say that there is studies reporting chloroquine, placebo, placebo quinine, quinine, and chloroquine. Similarly, there are studies reporting quinine, halofantrine, halofantrine with placebo, and placebo with quinine. So But there are no studies comparing chloroquine with artesunate, chloroquine with clindamycin, or clindamycin with doxycycline. So we can get indirect outcomes for this also, taking quinine as a common point because both chloroquine is means there are studies reporting chloroquine with quinine. Similarly, there are studies reporting clindamycin with quinine. So we can get outcomes for this chloroquine and clindamycin indirectly. Well, obviously there are two things which we need to consider during this comparison thing. One is this transitivity thing, and other one is consistency or coherence. So these are few of the sections which one has to report in their studies that how they are dealing with it. Otherwise, there is chances of a higher biasness in your study. So yeah, was a short video, I would say. Uh, I would strongly recommend you to download this dataset, and you can go ahead and run the same network meta-analysis for adverse event. You can check which is having greater adverse event, or which is how the plot is been visualized over here, what is the sucra, what is the league table, and so on. So till that time, maybe next Sunday I will try my best to explain it. If not, then we will try to go ahead with the new sections altogether, which is epidemiology. Yeah, that's what we are currently planning to go ahead. Like we will be doing studio. We have covered forest, subgroup analysis, then there was regression meta-analysis. Then we did network meta-analysis. After that, we did plan to go ahead with economic evaluation, but that will take a bit of a time because I currently don't have that much of resources to actually run economic model, cost effective analysis, for example. And just running it's not that tough because you can go through this code, you can just write it. But explaining it, getting the basic understanding of how and what this NMA and maybe your economic modeling are, those things are much important because you can check my codes, you can run it uh, as per your data set. But when it comes to understanding and making certain other people understand, that's where the main crux is. So I will try my best to provide you videos with whatever resources I'm having. It may take time, but I will try my best to give you the best. Okay, thank you so much for your valuable time. Have a nice day.